Assalamu alaikum, my dear students. I have already uploaded my two lectures related to theory. Now, this presentation will cover your lab performance. We are lucky that you have performed many identifications as you are concerned with organic compounds identification. So you have written on your practical notebooks, and now these slides will be very helpful to understand some of your previous or if you have forgotten your lab performance activities, so these will remind you those, because as you told me that you were not having any labs in your colleges, and it was first experience in university to perform such tests in your lab. So as you're always, most of the students, they put up question why practicals are important. So I have given this reply that why practicals are important. The main target of any subject is to clarify the concepts, and sometimes it is needed, it is must. Otherwise, without lab you cannot conclude your findings. So when scientists were exploring the different concepts, different theories, they were putting up different theories. They were also proving through their experiments that because as human beings trust on what we see. Simple to say, seeing is believing. And you cannot see molecules. If you are discussing that this is functional group organic or carboxylic acid, you are not able to see the RCOOH group in the compound. You conclude this group indirectly present in that organic compound, and that indirectly means you're using some tests in your lab, you're performing some tests in the laboratory. So during the findings, discoveries, actually those scientists were designing some ways, some reactions, some characteristic, because every functional group, why it is functional group, because any functional group has some characteristic properties, some characteristic reactions, like phenol is also an acid, and carboxylic, like benzoic acid, is also an acid. Both phenol and benzoic acid are acidic in nature. They both are aromatic, but due to functional group, they differ from each other. And in the lab, you can instantly tell which one is which. Now, it will be easy for you that either this compound is aliphatic or aromatic. The given compound is acidic in nature, it is basic in nature, or it is neutral. Heteroatoms are present or not. What are the functional groups? It is alkyl halide, alcohol, phenol, ether, aldehyde, ketone, amines, carboxylic acid, and there are so many other different functionalities present in the organic compound. Now you know hydrocarbons, they might be cyclic, they might be acyclic. Maybe ring is present in that organic compound, or maybe it is acyclic, that it has no cycle, it is long chain branched or whatever. Aliphatic and aromatic. Aliphatic means that aromaticity is not present in that compound, and aromatic, as I have told you, aromatic doesn't mean that it is containing benzene. Other than benzene, there are so many compounds which are aromatic in nature. I'm giving you just one or two compounds like cyclopropene cation. This doesn't contain any benzene in it, but this is aromatic compound. And cyclopentadiene anion, this doesn't contain any aromatic ring at all, but this is also aromatic compound because both cyclopropene cation and di- cyclopentene anion both are obeying Huckel rule. They are planar. So to show exhibit aromaticity, the molecule should obey Huckel rule. This is the basic central idea of any compound to exhibit aromaticity. If to check any compound obeying Huckel's rule will be aromatic at this stage. At this level, it is you have to learn at this stage. You have to learn that Huckel rule is the basic criteria for aromatic compounds. Okay, there are some, because most of the time organic compound is a carbon and hydrogen, but you know oxygen, nitrogen, halogens, sulfur, they might be present in the hydrocarbons. So you can check that what type of elements are present in the organic compound, given organic compound. uh, Generally we don't check hydrogen, oxygen uh, in the molecule. If oxygen is present, it could be found through functional group detection. Now in element detection, you can check whether nitrogen is present. You can check sulfur is present or not. Third, there is an option that nitrogen and sulfur, they are simultaneously present in the same compound. So you learn three things: that nitrogen is present alone, sulfur is present alone, but there is also a possibility that nitrogen and sulfur are both present at the same time. Now, after these three options, we have three more options that it may contain chloro, bromo, and iodo. That it may be uh, chloride, bromide, or iodide present in that organic compound. It is easy to discriminate amongst these three halogroups. Afterwards, we have a possibility, or we have option of checking its melting point. Every compound has specific melting or boiling point. After identifying functional group, we will move towards confirmation, because there are billion of compounds. They might have sometimes very close melting or boiling point under the same functional group. Most of the compounds, they might have same, although boiling point and melting point are characteristic, but as there are many compounds, there is possibility that some of the compounds may have same melting point. So at that time we perform confirmatory test. At that time we make some derivatives. Derivatives are again depend depends on the functional group. Functional groups, they give characteristic reactions like alkenes. I have told you they give addition reactions. Alkane cannot give addition reaction. Aromatic compounds, they undergo electrophilic substitution reactions, although they contain double bonds, but they prefer electrophilic substitution reactions rather to give addition reactions, because giving addition products, they will to retain their aromaticity. Otherwise, if they give addition reactions, aromaticity will be disturbed, and aromatic compounds never ever prefer their aromaticity to be disturbed. So when we make confirmatory tests, some products are formed, and those formed products for a specific organic compound will have specific melting point. So ambiguity due to same melting point of compounds will be removed when derivatives will be formed. Two compounds, two organic compounds having same melting point will have different derivatives with different melting points. I hope you will understand that uh, two organic compounds having same, for example, there are two compounds, A compound and B compound. A compound has also 200 degrees centigrade. B compound has also 200 degrees centigrade. Both are both are containing carbon, hydrogen, oxygen, and the functional group is same. carboxylic group. But the derivative of both A and B, when they are formed, they will show different melting points. And in the literature, you can check that this melting point matches with this compound. So you can identify which is A and which is B. Now, eh, there are two uh, ways to check organic compounds. You can check qualitative, you can do qualitative analysis, you can do quantitative analysis. Qualitative means which which atom is present in this organic compound, and quantitative means you can tell carbon in this ratio or percentage, hydrogen this, oxygen, nitrogen, easy. In other words, you can say this tells about elemental composition of the organic compound. So some during your lab performance, some standard protocols and methodologies are followed to conclude what is the structure of given compound. Now, as I told you before, that there are four major um, tests on the basis of which you conclude that what is the exact structure of the given organic compound. Preliminary test, element detection, functional group detection, and then derivative formation. Now students, that uh, we will see, first of all, before going through this preliminary examination, now you are coming towards wet and dry tests. So I didn't allow anyone to come in the lab without lab coat. This is for your safety. I have given you in the lab, in the class, before going to lab, that you have to follow safety measurements. You have written on your practical notebook and you have to follow. That is not just to write on the notebook, it is for you to follow. Because I told you that when I was in Karachi, in HEJ, we were not allowed without following safety measurements. And in foreign, when I was in Germany, they trained us before entering the lab, and they were very strict due to our safety. Okay, children, what tests you have to perform under the heading of preliminary test? First of all, when you are given this organic compound, instantly you can tell that it is liquid or solid. If it is solid, it might be in the form of crystals, or it may be powder, which is amorphous is the best term used in while you note down the state of your given compound. Color, if any, if you are very sure that this is the color of given compound, write down. But you know, many of the, there is possibility, not many, there is possibility for someone that he or she is color blind and cannot distinguish or tell exactly what the color is. So at that time you can mention that no characteristic color. But if you're sure that this is white or like water colorless, you can mention both colorless or white order. If never ever inhale, just if you're given the organic compound on some dish, just float that dish in front of your nose. I'm again telling you, don't inhale. it is dangerous. So if any characteristic or peculiar specific smell, you're feeling some, you're smelling some, you can tell. But there it is, like bleach, you use bleach, it is pungent smell. Rotten egg smell, bad smell, it is vinegar or some any fruity smell. Okay, you can distinguish, you can tell that this is, if you are sure that this is the smell, you can write down ignition. It will tell you that this is aromatic compound or aliphatic compound. You can check acidity, basicity, or it is neutral. If you have litmus paper only red, but students come, ma'am, we don't have any litmus paper, just lab attendant has given us red litmus paper, where is blue litmus paper, what we do? It is very easy. Make that red litmus paper, dip it in small quantity, take small quantity of any base in your test tube, dip 2 to 3 strips in the test tube containing base. What will happen, that litmus paper will from red turns into blue litmus paper. Wash it with distilled water and dry it. You can use, no, this has become blue litmus paper, you can use to check basicity of any given compound. Neutral, when blue and red litmus paper, they both don't change at all, it means that given compound is neutral. Okay, and now you are yourself observing that you have to be very vigilant for these reactions, because you have to observe. When you put ferrichloride, some compounds they become buff PPT, or they form some violet coloration because some complex formation takes place. So be careful during this reaction that what color you are getting. Sodium bicarbonate, because whenever any functional group containing carboxylic group or some other group, effervescence will be evolved. Effervescence, like when you open up your cold drink, bubbles are coming out from the bottle. This is the example for the what is effervescence. Bromine water tells you about compound is saturated or unsaturated, because addition reactions takes place when you add KMNO4 or bromine water. But there is possibility that some easily oxidizable compounds also decolorize, means the color of bromine water or KMNO4 changes from purple to colorless, yellow, brown to colorless. This means decolorization. So like, if you are if there is toluene means one of the hydrogen is substituted with methyl in benzene, or simply benzene with methyl group is known as toluene. When toluene is because aromatic compound, although they are containing double bonds, but they are not unsaturated. But when methyl is present, it should show no addition reaction, but methyl is easily oxidizable and it is oxidized into benzoic acid. So decolorization of KMNO4. So don't write that this is unsaturated compound. Toluene is saturated compound. Toluene is saturated compound, but due to easily oxidation of methyl into carboxylic group, we observe decolorization. So here we will write that some easily oxidizable compounds. There are many examples that compound is saturated, but it is decolorizing KMNO4 due to any moiety group present in the organic compound which is easily oxidizable. So you have two possibilities. It may be unsaturated compound or it may be easily oxidizable compound. So write both in your inference. Now solubility test. We use in solubility you use water. If it is instantly immediately soluble, it is very much polar compound. Ethanol is organic. You will use water, ethanol, sulfuric acid, sodium hydroxide and hexane. If soluble in hexane, it means non-polar compound. It's soluble in ethanol, it is organic compound. If it is soluble in sodium hydroxide, it is possibility that compound is base. If it is soluble in sulfuric acid, confirms or supports that the compound is basic. Water means polar. Ethanol, organic compound, any it is organic solvent. Due to hydrogen bonding, they are soluble in alcohol and water due to hydrogen bonding as well. Now melting point. Every organic compound has specific melting point. Derivative formation, I told you that to confirm functional group. Now I have given you one sample compound, acetic acid, and I have write some characteristic features of acetic acid in the result. And now this is the derivative formation of alcohol. So I hope and I'm sure I have made things easier for you to understand and to write you.